Hello, this is Pat, and number 2, we're going to make the fuse today, and I wanted you to come along with me and we'll make up the fuse. Now what I've done is I've gone ahead and I've turned it, and we turned up the fixture at the same time, and I cut both of them down to 2 1/8 inch diameter, and I did that at the same time so that they'll be the same diameter regardless of what that 2 1/8 actually ends up being. It ended up being 2.123. And number 2 is we will end up making up the ball to match it in the mill today. And so today, if you would come along with me, what I want to do is we want to make up the fuse and hang it onto the ball. And I'll show that to you now. And once again, we're back at the fuse. Now the fuse is just a 1 inch diameter by 2 1/8 inch diameter piece of steel, and it's rounded off to match the ball, about 9/16 deep. This gives the room for counterbore in the 5/16 screws that hold it and everything, and then there's a 3/8 tap in the end. Now I made this 2D drawing here because I wanted to stay on track and not get too lost with it as I was running around the shop, and it's real easy to work with and nothing special about it, but it's just something to keep me on track and working fairly well. This is the ball and fuse as it goes together in the assembly, and then finally it's the ball and fuse is used to hold everything in the fixture. Now on this 7/8 hex we just mount whatever the heck we want, a vise, a holder or some sort, and that should do it. Okay, thank you very much. Hello, this is Pat, and once again we're back here at the mill, and first thing I'm going to do is drill holes into this fuse. Now I set this up into a V-block which will hold it square, and clamped it in the vise which will hold it nice and tight. First things first, we have to check out and make sure that we've got the Z tool set correctly, which is going to be just barely down into the part a little bit right now. First thing I do is drop the tool down. And then use my pin to check it. Whoa. So if we're ready to run, we're going to drill 4, well, we're going to just barely touch 3 holes here, and we're going to run program number 42, which is active, so just run it. Now I want to run a 30-second clearance on these holes, which is going to be 5/16 plus a 32nd, which is 11 30-seconds, or 0.344, or tolerably close to 9 millimeters for those of you that are out in the world somewhere. Now, one other thing I wanted to talk with you about a little bit is how I'm doing this in this machine. All the tools are number 1. I just don't bother resetting them. The reason why I don't is because they're all different, and I'm going to use this drill to drill these 3 holes along with this tool holder. And that's it. None of it has to be planned out a huge amount, and I'm not doing it. So what I'm going to do is just use it, one tool, tool 1, and this is all, I just always leave it as tool 1. That way I don't have to think. I'm not sold on anything, etc., etc., etc. As I've often said, the great advantage to this type of machine, and this is a Milltronics MB20, is that they don't have any guards or anything in their way. And the bad thing about them is that they're not enclosed and they don't have any guards and stuff around them. So the only thing that keeps you safe from these machines is that you know that sticking your hand into a rotating cutter is a bad thing and it will hurt you. And the other thing is that you just don't throw stuff around out of them because it hurts. The other thing is that you do want to keep things a little slower, a little more intact in order to keep from throwing stuff out. But like I said, huge advantage in this. Easy to set them up, easy to get to, etc., etc., etc. Now, I'm coming down this tool, I'm stopping it. Now I know from programs that I'm 1 inch above it. I look up here, I'm 1 inch, 1 inch, 1 inch. It looks good. And I can go right on down and go down. I forgot to change the program to turn on the coolant, so I'll do it manually, and away we go here. Matter of fact, I forgot several things. Let's go back into this again. Let's just take a look here at program number 42. Now I'm running 1,000 RPM, so let's slow this down a little bit to say 700. And this time I'll remember to turn the coolant on. We'll just go with M8 and turn it on. And here's our drill statement. Now I want to go to some depth, about 5/8 thereabouts, but I want to miss everything, so let's go 3/4. Now that's my full depth. That's 754. I'm only drilling 750. You can see that I'm down through the part and I'm missing the V-block. It's fairly easy to check this. You can tell it, I'm good, I'm golden. So now I'm going to go ahead and run, start it. Now I'm not sure it's not going to go over to 0, first or anything of this nature, so I'm going to turn the feed way down. Always a smart thing to do. And first thing that should happen always in your programs is you should have a tool up motion. Now one thing that I can see here already is that I haven't drilled all the way through these because there's radius down here at the bottom. And you can tell it by just feeling under here. Now I can also tell you that there is no V-block under here, right where I'm at. And so I can just go down and check where things went wrong. And they have gone slightly wrong, but not a big deal. First things to do is to check my Z height. And make sure that it's still more or less where I sat it. And it is. So now I know I drilled 750 deep. So 813 will do it. Now, how about this one here? How deep should we go on this in the first cut? Let's go 900 thousandths. That's more than 815. Now, one more time, because I'm starting down in a hole, which is really kind of just asking for it, and really stupid, I'm going to turn my feed rate way down and come, oh, it is. Whoever programmed this was halfway intelligent and put a move up in first. And now we know that we're through. So let's go ahead and we'll move this on up out. I want to go Z positive to lift this out of the hole safe, nice and easy. Okay, so now we have it. I've got these 3 holes drilled in here. They have to be counterbored yet, which I will do here next time I have it and put this back in. They are nice and simple and easy. They're chamfered all the way around. It's a decent looking part. Life's good. So we're golden. So now we're going to pick this piece up. Second thing to do is to look and just look at your setup and make sure it looks half decent. Does it and isn't. And it does and it is. So now we're just going to lift up, put the machine back in neutral. Put our indicator back in. Make sure it's free. And it is. So now I can come down in Z. Zero my indicator. Now on the X I'm at 0 over here, so I'll come back this way and I'll come to 0 on the indicator. More or less about 0. It's more or less right there. It says it's 58. Half of 58 is 29. So what I can do is I'll come to 29. Close enough for this. And on the Y, I'm going to come out until I just touch it. I'm going to 0 it because I'm not very smart. I'm going to go back in to 29. And I'm pretty well there right now, believe it or not. At 29 thousandths off because my indicator just happens to have been set. So it's 1 under and 2 under. So I want to move my X about 1/1000th of an inch. And my Y an equal amount, about 1/1000th of an inch. What the hey, it's on YouTube. I'm going to come out and do my tenths indicating it very, very best. So there we go. It's halfway straight, plumb level and square. I'm at 5/10 and 5/10, so I'm going to 0 it, X and Y, raise it up some in the Z, and we're golden. Sure that the part's fairly straight. Now back in with my spot drill. I'm going to spot drill these all about 180 deep, just like I did the other one. And life should be pretty good. Mounted up my spot drill. It's in the chuck. Got to set my Z. Now, one thing I will point out to you is that there is a little bit of a nib right here in the middle from turning. Now, as it happens, I've got a 3/8 tapped hole into the other piece, so there's plenty of hole to clear it in the other piece, so I'm not going to worry about it. Other than it could conceivably throw me off a little bit here as far as pickup goes. So what I'm going to do in order to prevent that is I'm going to move slightly off center. Okay, so now what I've done is I put this back in and I've got it set up such that I can counterbore these 3 holes. Now what I've done is I've got this set up right so that I can come down and come to Z0. Now what I've done as far as it goes is just I want to, first things first, I want to zip on over here. And what I've done also is I've turned this such that everything's off 180 degrees. Now, under the general heading of complete insanity, I'm just going to do these by hand because it's much easier. Now what I've done here is I've set my cutter depth and I've set my diameter of tool, and I've set the tool just slightly undersized. And the reason for this is I want the hex to be plus nothing minus something. And this is going to allow me to burn the hex just perfect. And it'll be wonderful no matter what. In other words, if I burn it at 7/8 hex plus 20 or minus nothing, it doesn't matter. It'll be just great. And it's a heck of a lot easier to do it right at the moment. So I want to run an old program, number 7. And I'm ready to start it. And it should have a picture of a hex here in a moment. And it does, and it's going about faster. Okay, now this is all 1/1000th of an inch undersize, or 0.873874, 1 or 2 thousandths under, and that's perfect on this because I can burn this out to any old size onto whatever it goes onto here. About a 1/2 inch deep is what I plan on. So this part here, the fuse, is done, and we can move on.